Okay, so we'll start now. Sorry, the Blackboard is not working, so maybe it's for you as well. So I couldn't log into Blackboard to show few things. So we have to do away with that. So I couldn't log in actually. Anyway, so what I'm going to do instead, as it is not working, I'm going to do some problems on trusses. So solve few problems and ask. You can ask me any questions that you not getting on this topic, and then I'll discuss the test that we are going to have this week on your first topic, which is the reaction forces and the equilibrium. So I'll tell you what to expect and when that would be. So if I go to look at few problems. So first of all, I think we did problem 1 and 2. 3 is looking at that truss, problem number 3. Let me make it a little bit big. So problem number 3 is find all the forces, the members colored red, and also find the members force in member AB. So what you need to do is first find the reaction forces at the supports. So you will have two reaction forces at the left hand support and one reaction force at the right hand support, and taking moments about a point either of the support would give you the reaction force on the other support. Now how to deal with that 5 kilonewton inclined force? Now you can make that force, resolve that force horizontally and vertically, and then take the moment. So for the horizontal component, moment about this point, which is the left support, would be 3 meters. But for the vertical component, it is this distance, which is 4 meters. So you can find the moment. Once you find the moment, you find the reaction forces into the support. Is that clear or no? Okay. So the next problem is it says without calculation find the zero force member and oh sorry, I didn't say what about the member AB. So once you have got the reaction forces into two supports, you can start with the left hand support point and use member of joints to do all those members colored red. To get member AB, I would suggest take a section at this point and consider just the right hand part, and then that will give you the force in member AB. So possibly we'll look at that in this point as well. So this is problem number 4. Without calculation find the 3 zero force members. Okay, I think that's quite an important problem, and let's do that. So we have got 1 meter, 1 meter, 1 meter. So we have got a beam. Okay. So we have got a beam of 1 meter, 1 meter and 1 meter, and then vertical distance is also 1 meter. And then you have got these members, vertical members, and then inclined members like that. Okay, and these are pin support, those points. Okay, those are pin support, and then of course you have got the two forces in here, Now do note that in this case both are sort of pinned. Normally we have one pin and one roller, but in this case in this case okay, in this case both are pinned, and we have got a force of 10 kilonewton here. So this is 10 kilonewton force in this point. So first thing is for us to find out the reaction forces if we want to find forces into all these members. But before even we do that, let me name this point. Let's say this is point A, B, C and D, and then E, F, G and H. Now concentrate on the points where you have got two or three members connected at perpendicular angle or 90-degree angle. So one such point is joint B. So if you isolate joint B, so if I isolate joint B, so how does the joint B would look like? So this is joint B, for example. So we have got one member going that way and another member going that way and one vertical member over here. Now of course I have isolated this joint B by cutting it here, here and here. So this is joint B free body diagram. So I have cut in this way, I have isolated this joint B in this way. So this is this diagram over here. So this is free body diagram of joint B. So free body diagram of joint B. So I have isolated this joint B. Now when you have isolated, you have to consider where you have made this virtual cut. So you have made a virtual cut in member BG. So there is a possibility that at that point there is an internal force within that member. Let's say that force is F, B to G. I have made also another cut here. So there is a possibility of a force F, B to C. Now B to C and C to B are the same, because as we discussed last time, the force in the member in a truss does not vary along the length. So if it is 10 kilonewton tension at this end, it will be 10 kilonewton tension on the other end as well, and indeed along the whole length it will remain in tension and the same amount. Similarly, we have made a cut here, so that would give a force F to B to A as well. Now we have got these three forces now, and they have to maintain equilibrium so that this joint is in equilibrium. So if we do that, then we could see, of course, summation of horizontal forces 0. If I do, so summation of horizontal forces 0 would give me that FBA is equal to FBC. Nothing else. I get only the information these two forces are equal. So that means if this is plus 10, then this is also plus 10. If this is minus 5, this is also minus 5. So it means that these two are the same one. But if we do the summation of vertical forces 0, then that will give me FBG equal to 0. So this is important here, because there is these two forces will not have component in the vertical direction. So just by looking at this joint, so if you spot this type of joint where there is no other members on the other side of it, and then either horizontal or vertical equilibrium, would give a 0 force. So this member has got a 0 force member. So this is a 0 force member. So 0 force member would be, in this case, member B to Z. Can you identify anything else? Which one?
This is just part of guess, but do you think FC could also work as a zero force member? It's also
FG.
FC
FC, yeah?
because it is
Anybody agrees?
protected just like FBD.
Yeah, so if you take the free body diagram at joint F, then that would make FC also zero force member, and that you will get a free body diagram of joint F. So if you do the free body diagram of joint F, then you will find this is also zero. Anything else? FG, this one. So this one, if you drew the free body diagram of point F, let's say you make a free body diagram of point F, maybe going something like so. This is point F, okay? So what are the forces that would be? So you will have forces in point F in member FE, forces in member FG, and forces in member FC. Now summation of horizontal forces equal to 0 will give you FFG is equal to FFE. So not 0, unfortunately.
Could you please scroll down the paper?
Thank you. And whereas summation of vertical forces 0 will mean F of FC equal to 0, because that's the only force acting in this direction. So do you get that why FG will not be 0? FG, he said that FG would be 0. But
Didn't I say that FC would be 0?
FC is 0. Of course it is 0. But gentleman over there, he said FG could be 0 as well. Diagonal can be 0. Which one? CD. CG could be 0. Why do you think that? You think that C cannot be balanced because of this? Why not? If there is a tension force here, there could be a compression force in this one. Could balance. Without doing the calculations, we are not sure that this could be 0. But definitely this could be 0, because considering the equilibrium of this point means that this would be 0. So, go on. Why that? Not FG0, FC0. Sorry, my handwriting is probably. Sorry. Thank you. So this member is 0. Yeah? Is that okay? Got it? Okay. Now, what about this member? If you consider joint D, can you say anything else could be 0 here? CD could be 0, because if you isolate joint D, very good point, thank you. So if you isolate point D, for example, here, so joint D is here, let's say this is joint D, and I have got two member forces acting here. So one of those is force in, so I have made a cut there and there, so that would be F D to E, and there would be another force here F D to C, and of course there is, at that particular point I have got a 10 kilonewton force. So summation of vertical forces 0 will give me FDE is equal to 10 kilonewton, because that is balancing to each other. So FDE is in tension, and that would give me that 0. But if you do summation of horizontal force 0, that will give me FD2C is 0. So that is another member I need to add in here. Member C2D or D2C is 0, and we get that by doing free body diagram of joint D. So we have identified 3 members so far which will have 0 force. Anything else? No? Mm-hmm.
And so the force P to B would be 0 in that case, right?
You wouldn't know. You wouldn't know. So you will know C2D is 0 only when you analyze point D as 0. Now, why it cannot be 0, if you think? This is definitely would be 0. So if you analyze joint C, then that, so let's do that. So let's do joint C, analyze joint C. So put joint C in here. So you have got how many members? 1, 2, 3, I've got 4, and I've got 5. So this is joint C. Now I have got various forces acting in there. So this is 0 force, nothing there, because we know FC equal to 0. This is also 0 force, we already know. Can you see it now? Okay, sorry. So these two are 0 forces, we already know. So this one would have, let's say it is F C2E, and this is say F whatever C2G, and this is say F C2B. So there are 3 forces here, they can balance. So if one of them is tension and one of them is compression, then that will balance the vertical component, and then horizontal component would be balanced by the other one. So it's possible. Okay. So in fact, if this is tension, that would be maybe compression. So both horizontal reaction would be on this direction, from component for these two inclined forces. So this must be on the other direction. So compressions maybe. Okay. So if the point is, what you raised is right, that if at a member at one point, one joint you analyze, the member force is 0, it would be 0 all along. So it will be 0 at point C as well. Is it okay for this one? Findings is not needed first here. Okay, so if we do need to find out these forces, how do you think you will go about it? Any quick way? So if I need to find out what is this force FCE, what I am going to do is as follows. So I will take let me zoom it up. So I'll take a cut of this side maybe like this way. Can you see it? Okay. So if I take a cut along this way and then replace those wherever I have made cut, I'll put a force. And then this side there is a force as well. And I call them, this is from F D to C, and I know this is 0 already. So there is force here, F E to C, and there is F E to F. Okay, so these are the member forces. So it's quite easy now for me to find out what is the force E to F or E to C would be. How do I do that? Now, of course, if I take moment about a point about which I can get rid of one of those reaction forces, either EF and EC, then that is useful. So, for example, if I extend that, and then there is my point C somewhere here. So there is point C somewhere there. So point C is somewhere there. So if I take moment about point C, so moment about point C equal to 0. If I take that, then moment due to DC would be 0 because that the force is 0 anyway, but also that passes through point C. Moment due to EC would be 0 because that passes through point C. What about FEF? There would be moment. So FEF times the distance. So distance, perpendicular distance from this point is 1 meter. And then you have to see what sort of direction that moment is. Now that force about point C will rotate my pencil in the counterclockwise direction. So always put a lever or a hinge or a rotation point about which you are taking moment. And then imagine the force is trying to rotate your pencil about that point. So I am taking moment about point C, and these forces I am calculating moment about. So how this will rotate? This will rotate my pencil in the opposite directions of the clock hand. So that would come with a negative sign. So anti-clockwise moment. Now let's see what about the 10 kilonewton force. Okay, I put my hinge there. Let's do it step by step. First, moment I am taking. So write down the force, which is 10 kilonewton. And what is the distance? Distance is perpendicular distance. So distance is again 1 meter. And now you calculate the direction. So put a hinge here, and the force is in this direction, which is again in the directions of the clock hand. So that is positive. So that equal to 0. So FEF is equal to 10 kilonewton. So I know FEF is 10 kilonewton. Now it's much easy to find out what would be this one, because you can take summation of horizontal forces 0. So if summation of horizontal forces are 0, there are how many forces here? 1, 2, 3 and 4. So FEF is going that way. So you put it as minus FEF. You are too polite. You should have said long before. Because I am looking at here, so I cannot see that you have raised hand. Just shout. So FEF is in this direction. So I am taking this direction force as positive. So FEF is in this direction. And then component of EC in this direction. So if this angle is 45 degree, from the diagram it looks like. So its component along the horizontal direction would be minus FEC cosine 45 degree. And other two forces will have no component in the horizontal direction. This would have, but it's 0. So that equal to 0. FEF already we know that is minus 10. And FE to C cosine 45 degree we know square root of 2 is equal to 0. So FEC would be again that would be minus 10 square root of 2 kilonewton. So that probably would be 14 point something kilonewton. So FC2E is actually compressive. So this negative sign means it's a compressive force. So if it is compressive, then this direction is opposite. So coming back to your point, so truly speaking, this direction is not in this direction. It is actually in this direction. So that is compressive. So if this is compressive, then how the balance should be? So you can see vertical component are balanced. So this should be balanced by that one. So if you say summation of vertical forces 0, you will see this angle is 45 degree. Thank you. Thank you. Why am Yeah, okay, thank you. So if you take 45 degree angle over there, then summation of vertical forces 0 would give you FCG is equal to FCE, for example. The numerical value would be there. So FCG is in this case taking into this sign. So FCG is in tension and the same value as 10 root of 2 kilonewton. So FCG is 10 square root of 2 kilonewton and that is tensile. That is tensile. 10 square root of 2 kilonewton. What about CB? Its component in this direction. So CB would be negative. So if you do that, summation of horizontal forces 0 and let's say forces in this direction is positive if you take. So minus FCB. So this is going this way. And component of this in the horizontal direction is again minus FCG sine 45 degree or cosine 45 degree, same value. FCE again going that way, so minus FCE sine 45 degree equal to 0. So that will give you FCB. Okay. So FCB value then you will get from here, which would be the summation of these two horizontal components, and it will be negative as well. So this value is known, this value is known, so you can find out what is FCB. Okay. So FCB would be negative of these two. Is that okay? So this way then you can find out forces in all the other members. Okay, now let's talk about quickly, because it's a halfway mark. I think everybody is here. Let's talk about the test. So the test for other tests, there would be 4. Let me write it down. Have you written it down now? Yeah, is that okay? Any question on this part? No? So there will be 4 online assessment. So assessments are, one is a group work, which I will give you details. I think week 6 I am going to give you, which is next week. I am going to give you details about the group work. So group work could be in a group of, haven't decided, maybe four people, maybe 4 people in a group. And what you have to do is you have to analyze an object from its structural point of view. So object could be, for example, this visualizer, its weight, how it is supported, whether there is any bending involved, or any, it is like it's a truck, how it is carrying this load, for example. It could be simply a desk, or a door, or a chair, or any object, for example. So, or a sculpture, for example, you see outside, or a tree, anything, natural object, man-made object, anything. So anything that you see you have to analyze it from a structural point of view. Estimate the load, how the load is supported by that structure. So I'll give you some example from the past years next week. And it will be 4 people in a group, so it will be marks mostly by the group. And I don't want one person to do all the work or 2 person to do all the work. And neither I want 1 or 2 person not to do any work. So everybody has to work equally. And if that is not the case, I'll ask you to put in a peer assessment that you have to agree how much percentage of the work you have done in there, and then the marks should be allocated on that basis. But also I would be careful that sometimes the students, sub-students are sort of too controlling in that way. So, okay, I'll do the work. I know this subject very well. So I'll do all of it. You guys don't know much. So that I'll actively discourage as well. So it has to be a group work. Marks has to be on the group performance. So this is 20% of the total unit assessment. So submission deadline, I think I said week 11. So it will be issued next week. And every year I ask the class, how do you like the group? Would you choose your group or you want me to randomly allocate? I get different answers. Okay, let me get a show of hand. How many of you would like to choose your own group? Okay, how many of you don't mind if it is randomly allocated? Okay, how many of you really like randomly allocated one? Okay, good. So overwhelmingly you want to choose your own group. There is a positive and negative both, because you tend to choose your friends, you tend to choose your people you live with or nearby, and then that doesn't mean that your skills and knowledges are complementary. So that is an issue very quite often. But being it first year, I know it's probably difficult that you haven't met everybody yet. You don't know that much, and it may be difficult for you to coordinate the activities. So I'll think about it, what I'll do, but I'll let you know definitely next week whether it will be randomly allocated or I'll choose, or a mix. I'll probably let you choose first, and then whoever is left out, I'll randomly allocate. Something like that I could do. Okay? So that's next week. And next week I'll show you some example as well. Then there would be second set is term time online assessment. So term time online assessment would be 4 of these, and each one at 10%. So in total 40%. So total would be 40% of that 4 online tests during the term time as given in the coursework timetable. And third is the end of term assessment. So this would be, this is in January, so January 2022, and that would be 40%. That would cover the whole syllabus, the final January one. This one would be topic by topic. So the first one is, what I'm planning is this week, because of the way it has been organized in this semester, so it would probably be, not probably, so the first one from 2, so number 2, the first one is on reaction forces and equilibrium. So that is reaction forces and equilibrium. Now reaction forces means that I may give you a truss and then ask you to find out the reaction forces. I will not ask you to find the member forces, but I can give you this truss, for example, and say, given this load, find out the reaction forces at these two support. So if it is look at truss, don't be saying, oh, okay, truss was not supposed to be in the test. There could be a figure in Truss, but that would be asking the reaction forces. Now it will be, we have got a tutorial on Friday, isn't it? So Friday would be 29th, I think, yeah? So Friday 29th, October, and it's 4 to 5. So these hours we'll have this tutorial. Now, how we are going to have this tutorial? It will be in the engineering building, the new building that we have the tutorial. So if you have got a device, any laptop, iPad, tablet, a big sort of mobile phone would do even, as long as you get into Blackboard. So bring that along. So mobile phone is fine as well. You could see that. Those of you who do not have, I'll get those GTAs to book couple of those computer outside that engineering building B, lecture theater B. So you could use the computer outside as well. Now the test will be, I haven't decided, but most likely be maximum for 25 to 30 minutes. And there would be a timer. So once you start, you have to finish within 25 to 30 minutes. And you will be, of course, sitting next to each other, given the nature of it. But most likely, your problem set would be different than the next person's set. Okay? So it may look similar, but it will be also different for everybody as paper. Yeah.
What about, is there going to be any way to prevent people from looking at each other's papers? Because I'd be more than happy for such a thing.
Sorry, to next persons.
Are there any ways that people can ensure that others don't look at their computer or their work?
Okay, that's what I said. So there would be all this 4 or 5 GTAs and myself would be available. But on these lecture theater, it's very difficult for me or anybody else, a person behind you, may look at your computer. So that's why the questions should be different. So you will get a different set of questions than person behind you. Okay? So there would be, so everybody will get a ever so different set of questions. So it's not like question 1, tick number B, for example. Question 2 is C. It won't be like that. So it will be all different, and many cases you have to calculate certain values. So please bring a calculator and some spare papers. If you have to do the calculation. If you want to do the calculation on your computer, that's fine. And as in this format, it will not be possible, and neither would I want to stop you using internet. You can. If you want to look at the books, you can. Notes, you can. Absolutely fine with me. So, but don't bring books of this length with you, because let me tell you, they would be not much use. So just revise and come up to the test, and it will be just testing your understanding. So no amount of, you will not find those problems in internet, or internet will not be able to solve it for you. So you have to know the process that we have done it through. If you know that, probably you will be able to finish the whole test within 10 to 12 minutes maybe. No longer than that. But that's about it. So that's a challenge for me as well to devise the question, but I'll try my best. Go on. You first. You raised your hand.
I was just going to ask, do you have any idea how many questions it is? So you said 30 minutes, but is it like effectively questions?
Yeah, the number of questions do not matter, because I'll be keeping an eye on the time. So if I'll assume that I take probably 10 minutes to solve, I'll definitely give at least 20 minutes for you to do, plus few other minutes. So if I say, okay, this test would be for 25 minutes, then I would probably be able to solve that in 10 minutes, and I would expect you, by the end of this course, to solve that in 10 minutes as well. Okay? So there would be enough time, but of course not so long that you spend, so if you get stuck in one problem, then move on and do the next one. Because you can see all the problems at a go, so it's not like you have to come back one after another. Yes, you. Again, I answered that, so doesn't matter. So it's with the time. So it could be 2 questions or could be 20 questions. Doesn't matter. Yeah.
Is there a practice quiz? Practice quiz.
Practice question, all these tutorial problems and those that we have done. So if you know those, that should be fine. Yeah. Sorry? Yeah, so the question should be slightly different type. Multiple choice, yes, there will be some. There will be some where you have to put in a value. Most of the questions, you have to calculate something and put in a value. Maybe some questions where you have to write a short paragraph, for example. Some questions you may have to click on on an image. So I may give a problem, say not this one, maybe Truss or something, and say click on this image. Where do you think zero force member is? Something like that. So you have to click on that particular image for that matter. So there would be a variety of type of questions in there, and some cases you may have to write a small sentence or two or a bit of calculations there. So please bring calculator and a piece of paper to do the calculations. And what else I need to say for this test? 10%. Nothing else from my side. Any other questions on the test? No? Okay. So I'll try to design as much as possible so that collision doesn't happen between, although you are sitting next to each other. You don't get similar set of paper. Yes, there could be, there are 2 types of, yes, that's the point I wanted to say. There are 2 types of multiple choice questions. One where there is only one question is, one answer is allowed. In blackboard, that is given by this circular choices like choice A, B, C and D. So that means you choose just one. If you choose B, then you cannot choose C or D or anything. But there is also in blackboard a square button, for example, square radio button. And here multiple answers are possible. So you could choose in this case B and C, for example. So if this is this type of questions, then there would be negative marking, because as you know, you could click all 4 and the correct answer would be among them, right? So there would be negative marking for definitely for the square radio buttons. So if the multiple answers are possible, those questions will definitely have negative marking, but it will be written in the question text as well, that this question has got negative marking. For the first one, I'm not going to put any other negative marking except that type. So, but subsequently, possibly I will, so that you put in the one you definitely know. So current in the first test, there will be no negative marking except for the square radio button. Okay, and it will be few of those maybe, and some of those other. There will be a matching type as well, so I could give, okay, you have got few things on the left hand side, few things on the right hand side, match between this to this. So so the top one would match with the third one from the right, quantity something, and then and those sort of questions would be also there. Okay, so let's give a go and see how it goes, and then we'll improve that in the next one. Okay, because last year it was not possible to do invigilated one, so it was given and then people did it and returned it from home, and no way to check whether they solved it in a group, or some uncle or aunt or brother or sister helped them. But I was in a way satisfied that as long as you, that's what I reinforced, that as long as you knew what is you solved and what is required, you went through it, that probably satisfied the learning outcome. Okay, so any other question on the assessment? No? Yeah. No, because then I wouldn't know exactly the last bit, whether an uncle or aunt are sitting next to you. So that's the point. If you cannot attend Fridays 4 to 5, there is virtually no other way except you have to put in a mitigating circumstances form. So if you are aero or civil, either contact your administrator or just a standard one MACE student support at manchester.ac.uk saying that you want to put in a mitigating circumstances because you missed this test as coursework, and then depending on the mitigating circumstances of yours, the committee would give you some ideas how to resolve that issue. So no, I wouldn't allow that. If you have to, you can take it from home or anywhere else. You have to come there. Okay. Okay. Any other question on this one? No. What I'm going to do is, somebody told me as well that the tutorial answers are not uploaded. As soon as the Blackboard is back up for me, then I'll upload the solution to the last week's, the week before's tutorial, and then I'll also put the answer for this tutorial Truss as well. Okay, so both of these tutorials would be there. Okay. Any other things? Okay. So we are going to start a new topic on Thursday. So please make sure that you do this Truss problem well. Truss would be the next online examination. So 2-2 would be on the trusses. Okay, so make sure you do the trusses. Okay, good, thank you. So see you on Thursday, and Friday is the test. Yeah.
So this question, you said FCE, which is this foresight, it's negative, but isn't it supposed to be positive since its horizontal component is to the right?
So I have drawn it like I know this is negative from some other calculation, so that's why I have drawn it in this way. So if you want to do it in that way, you take that as a negative force. So FC would be minus 10 over root 2 if your force is in this direction. If it force is in that direction, then you can take it as a plus.
Thank you.
Over here you said FEC is 0. Why is that?
FEC is not definitely not, I said.
How do you take moments per C?
So moment of that force is zero, not that force is zero.
Why is the
So
moment 0?
because this is, I'm taking moment
No,
about point.
no,
Yeah,
just
please.
figure out.
Thank you. The force is going through point C, so that the moment of that force.
Oh, I see. Because you take moment about C.
Yeah.
Excuse me, I'm unable to chip in for the MACE110.
Yeah, the Blackboard is not working, as I said, so it is
So
not
it
working
won't
for
be
me.
a problem?
And if Blackboard is not working, how can it be a problem? No, possibly not. For attendance. Yeah. And Blackboard is not working.
Oh, really?
Yeah. Yeah.
How would I calculate the force here for FCP?
So you are still considering that way, right?
Yeah.
So FCB, so let's take this direction is positive. So FCB is negative. What is that? CG.
Yeah.
So its component is also in this direction.
Yeah.
So minus FCE.
Close 45.
And this force is in the other direction. So plus FCE cosine 45 degrees. So now this value is minus 10 over square root.
Yeah. Oh, what about these two?
So this one would be tension, right? So this is plus 10 over. So you find it.
Why is FCG
Why 10 root 2?
Because if you take the vertical equilibrium, then that will be cancelled.
Oh, I see, they're the same. Right, thank you.
Oh, things Alistair, okay?
Yeah, not bad, thank you. You alright?
Okay, okay.
Just ran into Andy on the way in, saying we should have
Yeah,
try and have
meeting.
another meeting.
Yeah, because
Keep the momentum
these
going.
next 4 weeks, week 5 to 8, is very busy because I've taken over, had to do for Andrew Foster's 4 weeks as well. And plus another MSc course starting this week as well. So now I have got 3 hours MSc. I don't know how, whether they take into account the timetable or not. That as long as it's there, that's fine. So 4 hours continuous.
Anyway, I mean, I think as long as we get it moving before Christmas, I think, and I'm happy to, I said to Andy as well, I'm happy to just help behind the scenes. Like, I've got enough official stuff on, but I'm happy to keep things moving. So if you need something done, just let me know.
See you.
Right, see you in a bit.